Hi everyone, another important question regarding the physiology portion of MRCS. A healthy man has a blood pressure of 120/80 millimeter mercury and an intracranial pressure of 17 millimeter mercury. What is the approximate cerebral perfusion pressure? So we have to find out the cerebral perfusion pressure. That means the pressure which is required for circulation of blood in the brain or perfusion in the brain. So this is the normal blood pressure, which is 120/80 millimeter mercury, and intracranial pressure, which is this 17 millimeter of mercury. So we have to find out the cerebral perfusion pressure, or we have to calculate the cerebral perfusion pressure. Here we can see the options. Options are 103 millimeter mercury, 63 millimeter mercury, 83 millimeter mercury, 91 millimeter mercury, and 76 millimeter mercury. So we have to find out one of the option, or we have to calculate, and finally we have to get a number which is compatible with one of the following option. So first of all, what is cerebral perfusion pressure? It is the pressure. This pressure is required to maintain the normal blood circulation in the brain. So here we can see the cerebral perfusion pressure. It is the mean arterial pressure minus intracranial pressure. So first of all, we have to find out the mean arterial pressure. Then we have to minus the intracranial pressure from the mean arterial pressure. Here we can see the intracranial pressure here is 17. So first of all, we have to find out the mean arterial pressure, and we know the mean arterial pressure, that means average arterial pressure. It is the diastolic pressure plus 1/3 of the pulse pressure. Here we can see the mean arterial pressure, which is the diastolic pressure, plus 1/3 of the pulse pressure. Pulse pressure is the difference between the systolic and diastolic pressure. And here systolic blood pressure is 120 and diastolic blood pressure is 40. So diastolic blood pressure is 80. So when we difference is 40 millimeter of mercury. So diastolic pressure plus 1/3 of the pulse pressure. Here pulse pressure is 40 millimeter mercury, and when we multiply with 0.33, then it comes about 13. And diastolic pressure is 80. So 80 plus 13, which is the 93. So here mean arterial pressure is 93. So here we can see in this situation mean arterial pressure is 93. Actually it is 93.33 or something, but which is removed only 93. So mean arterial pressure here is 93, and cerebral perfusion pressure is the mean arterial pressure minus the intracranial pressure, and mean intracranial pressure is 17. So here we can see mean arterial pressure minus intracranial pressure equal to cerebral perfusion pressure, which is the 76. So our answer is ready. It is the 76, which is the cerebral perfusion pressure. And cerebral perfusion pressure is the net pressure gradient causing blood flow to the brain, and that means cerebral perfusion pressure must be present to maintain the normal blood flow in the brain. CPP, that means the cerebral perfusion pressure is tightly auto-regulated in a certain level, because brain is a very vital organ and very sensitive to hypoxia. So 4 to 5 minutes of hypoxia is enough to infarct the brain tissue. And a sharp rise of cerebral perfusion pressure may result in rising intracranial pressure. Fall in CPP may result from cerebral ischemia. So intracranial pressure when intracranial pressure increases, in this condition cerebral perfusion pressure increases, and in case of ischemia cerebral perfusion pressure decreases. And following trauma, the CPP has to be carefully controlled and may require invasive monitoring in case of the intracranial pressure and mean arterial pressure. Actually, after any trauma or emergency condition, it is very, very important to maintain normal cerebral perfusion pressure. So it is now our answer. It is ready that the cerebral perfusion pressure, it is 73 millimeter of mercury. Thank you all.